Okay, so in the first set of videos, we talked about the concept of return. Now we're going to talk about the concept of risk. So what is risk and how do you measure risk? There are many ways that you can measure risk, but one of the ways that you can measure risk is using what's called the standard deviation. The standard deviation is the square root of the variance. Sometimes the square root is called the volatility. Standard deviation is handy because it is in the same units as the average. So standard deviation is a measure of dispersion of the returns, and it measures the risk of the stock. In this case, it's how the stock is moving up and down erratically, right? Or how much it moves from about the mean. That's what the standard deviation is. And then you have a normal distribution. A normal distribution, of course, is a bell-shaped frequency distribution that can be described with only an average and a standard deviation. So let's look at the idea of risk in the form of a frequency distribution of returns on common stocks. So right here you have a graph that shows you the returns for each year over the 1926 to 2012 period. So as you can tell in the right-hand side of the graph or the PowerPoint, right here you have 1954 and 1933. So those 2 years are the ones that provided returns that were above 50% or more in this particular time period. The majority of the returns, right? The majority of the returns or the annual returns have been concentrated right here above 10% and below 20%. So some years have actually been pretty negative, like 1931 had a really, really bad year. The returns were closer to minus 40 to 50%. And what you have here is you have like a bell type distribution, what exhibits a little bit of skewness and maybe a little bit of what's called fat tails, but you can see it's like a bell curve. So some returns have been very high, some returns have been very low, and that is what we call risk, right? Like the spread between the high returns and the low returns. So what is the formula for standard deviation or for variance? Variance is just the squared of the standard deviation. So if you look at this formula right here, this right here is the variance of the return, okay? Which is what we call a sigma squared, And the variance of the return is just the return. For example, it could be like the annual return minus the average return squared. And you sum all these squared deviations and then divide them by n minus 1, n being the number of years in your sample. So you sum all the squared deviations and then divide them by n minus 1. Once you get this number, the variance, then you take the square root of the variance to eliminate the square that you see right here, and you get what's called the standard deviation of the return. So, so the standard deviation of the return is pretty much this formula, but the square root of it. So if you look at this figure right here, or this slide, you'll see that large company stocks have had an average return of 11.7%. and a standard deviation of 20.2%. And this is the frequency distribution of the returns. Now, if you compare that with small company stocks have averaged 17.5% per year, and then have had a standard deviation annually of 36.6%. So the larger the number, the larger the standard deviation, the larger the risk or the variability or the volatility of the returns. So if you look at the standard deviations right here, large company stock portfolios have had lower risk than small cap portfolios would have had. And at the same time, the returns for large company stocks have been lower than the small company stock returns. So that kind of shows you the variability of these returns. If you look at the frequency distribution here of the returns, notice that the range or the spread is much higher for small company stocks. Right here you have extreme returns right here, and you also have extreme returns over here compared to the large company stocks. So more risk compared to large company stocks, and at the same time more return compared to large company stocks. So that's the relationship that's super important in finance, that higher returns are due to higher risk that investors take. So look at this normal distribution, or this bell curve. This is what they call a standardized distribution. So the value here of 0 is actually the mean. So the mean in this case is 11.7%. And then the +1 standard deviation is when the variable is above 1 standard deviation from the mean. So this is for large company stocks. 11.7 plus some number gives you this 31.9. Okay, so it's 1 standard deviation above the mean. If you look at the prior graph, the standard deviation was 20.2%. 20.2%. So 20.2% plus 11.7 gives you the 31.9%. So that's 1 standard deviation above the mean. This over here means 2 standard deviations above the mean, and then 3 standard deviations above the mean. Similarly, on the left-hand side, you have -1 standard deviation below the mean, or -2 standard deviations below the mean, or -3 standard deviations below the mean. So it's 11.7 minus this 20.2. 11.7 minus 20.2 gives you the -8.5%. So in a given year, for large company stocks and with the sample that we have, in a given year, 68% of our years, right, 68% of the time, returns are going to fall between -8.5% and 31.9%. That is 68% of the time we would expect to see the returns falling between -8.5% and 31.9%. Then if you go 2 standard deviations above the mean, or 2 standard deviations below the mean, that represents 95% of the observations. That's why you have this 95. Returns are expected to be between -28.7 and 52.1%. And then 3 standard deviations above or below the mean would be -48.9% to 72.3%. This is the distribution, or the frequency distribution, or normal distribution that we're seeing of these returns. So you can be 99% confident that returns are going to be, in a given year for large company stocks, they're going to be -48.9% or 72.3%, like in between those two numbers, 99% sure. 95% sure these two ranges, and then 68% sure this range. So that would be the normal distribution for large company stocks, given the mean of 11.7% and the standard deviation of 20.2%. So let's look at the historical risk and return trade-off for different types of assets. So you have small company stocks over here. Small company stocks had really high annual return standard deviations, but at the same time they had really high returns. For large company stocks, the standard deviations were lower, but at the same time the returns were lower. For treasury bonds, the returns were lower in a year. The standard deviations were lower in a year, but the returns were also lower. And then for treasury bills, standard deviations were very low and returns were actually very low. So this is this positive risk-return relationship that we're seeing. The higher the risk, the higher the return. This is what you see empirically.